Okay, let's continue. Actually, a little bit more, maybe 4 or 5 more slides for secondary covalent bonding. So we already done primary bonding this morning. So primary bonds, we have 3 types: ionic, covalent, and metallic. There are 3. Then within the primary bonds, when there is a mention of mixed bonding, then there's a mixing of these 3 types of primary bonding. It can be ionic covalent, metallic ionic, and the 3 ionic covalent metallic. Okay. So second half, we go into secondary bond. Now, secondary bond is very, very weak compared to primary bond. So this morning, what we talk about is primary bond. So this afternoon, we look at secondary bond. They are very, very weak. How these secondary bonds are formed? They are the attraction of electric dipole. They are electric dipole between atoms and molecules. Okay, the attraction of electric dipoles. So they are secondary bonds. So like the diagram that you see on the screen here. So you have a positive and negative charges. So the distance is the distance of dipole. And then in the physics, you know how to calculate moment? Physics, or in static, you take static, right? So how to calculate moment? Okay, so the force must be perpendicular to the distance. Then only it will create moment. So moment equal to F multiplied by D. And both must be perpendicular to each other. Okay, so here, when there's a form of charges, the distance and that one, so they will form a dipole moment, which is a Q multiplied by the D. Okay, Q multiplied by the D, it can be referred to the positive charge or negative charge. Same, create the same moment, right? And then the second diagram, it tells you that how you illustrate the secondary bonding. Okay. There's an equation. Equation is mu dipole equal to mu Q multiplied by D. Mu equal to QD. So you take the charges, multiply by the distance compared to the center of the 2 molecule or atoms. Okay. So they are conversion unit. Some textbook they use dBi equal to certain columns, right? Certain columns, they also constant value. This one, if the question asks you, it'll give you equivalent numbers. Yeah. So secondary bonds, sometimes they are called van der Waals bonds. Van der Waals bonds, they are forces, but in this module, I don't go deep into van der Waals bond because they are secondary and they are weak forces. So for mechanical or civil engineering, if you deal with weak forces, it doesn't make any good to the structure. Right, so we don't study a lot of. We do look into secondary, but we pay more attention to primary. Okay. It is because of the dipole, because of the charges. They are formed because of charges. They balance each other at a certain distance. So the charges, the forces between them is very weak. Okay, the rest you read. Okay, this one also you read. For example, van der Waals, normally they are example of a normal gas, krypton, helium, all these that are formed by a secondary bond, and their melting temperature are negative. because you only need a little bit of energy, then they break away already. So that's why you see a negative melting point and boiling point. Okay, very, very weak. Okay. So why the melting and while the melting and boiling point increase, so you see the value is actually increased. So from negative to a more positive number. From negative to a more positive number, it's actually increasing. Okay, so if you look at the periodic table again, and you're referring to helium, neon, argon, krypton, this row. So as you move down, the atomic size increase. Okay, due to a stronger bond force, since electrons have more freedom to create stronger dipole moment. Okay, why? The dipole moment give you what equation? Q multiplied by D. So if the D is large, so this is molecule atom A, so the distance is large. If the D is large or the radius is big, so your moment is increasing. Moment increasing, boiling point increase. You need more energy to break them. Okay. Okay. So they have a permanent dipole. For example, methane. Okay, methane they have a CH4. Melting point minus 108 Celsius. So these have a single dipole moment. But this CH3Cl is more complicated. You change the H to C, right? So you will change, once you change the C, there's a moment change. Of course, what is the conversion is 2 slides before this. Tell you the 2 slides before this. The rest you read. Okay. One thing I need to mention is hydrogen. Hydrogen is a very special element. They have a permanent dipole-dipole interaction. Research in hydrogen itself can give you up to a PhD level, only looking at hydrogen. Okay, so hydrogen is a very special element, including the water. H2O is a special element in this earth. So give you an example. Freezing of a glass of water. You see what happened to the glass? Why there's a crack there? So water is a very special element. Sometimes they expand and expansion at a certain temperature, right? So water also, that's why there's your devices rupture. That's why early machine that use water in the cold weather, we at a tropical country, we don't feel the damage. But those you live in the 4-season country, especially with the winter, most of their engine breakdown, especially the water, the radiator that you fill in water, most of the time they will have problems during winter because of the water properties. So also they create one serious problem when it come to military application. It will also makes most of the weapon not functioning during the very low temperature, right? Yeah, so this one, there's a science there. There's a science there. So the rest you read the remaining of the slides. Okay, hydrogen is a very special element. Okay, These are all the example on automobile cooling system. On cold country, you will break all this, right? Yeah. Road also, in the cold country, some of the road they also break because of the water properties. Our road because of heavy lorry or heavy vehicles, but overseas they break not because of the heavy machine, but because of the water properties. They freeze and then the water expand. Then, yeah. Okay, so there are some orientation there. Yeah, but I won't ask you on in the test lah. Okay, so your homework is to look at this diagram and then explain the relationship between the parameter and bonding type. For example, ionic, covalent, metallic, van der Waals, hydrogen. Why the energy is different from ionic to covalent, and then why the temperature change from 800, it can, when it come to a certain element or certain bonding type, it can jump to 3000. Okay, so you should able to explain why the bonding energy is increased, why the melting temperature increased. Explain using the bonding theory that you learn, primary and secondary. Okay, so this also one of the popular question. The question might be very short. It give you a table, something like this. Explain why ionic NaCl and MOG, why the two different value here. Okay. So the answer is in the slides lah, in all the slides there. So these are all the example question that might come out from 1 to maybe 10 or 12, right? So these are all the question you can go through and see whether you're able to answer, right? So some ask you about the periodic table, and then we give you the correct configuration here. Then you go and check what is this element, what is this element, what is this element. Okay, so this is a reverse kind of question. Your question give you this one. Are you able to identify what is the element of this configuration? So you just go through the periodic table based on the SPDF, N3D, 4D, and so on. Okay. And there's a question on the bonding force, energy, and so on. Then interaction bonding, problems, and so on. So with this, we conclude chapter 2. Okay, I end the recording, then we start chapter 3.